We treat cables like such an afterthought.
Oh, always.
You'll spend like $3,000 on a projector, mount it perfectly on the ceiling, and then connect it with some bargain bin wire.
And then everyone's shocked when the image sparkles or just cuts to black.
Exactly. So today, we're fixing that. We are doing a deep dive on this one cable, the NTI HD4K18GB-FO-10M-MM.
It doesn't exactly roll off the tongue, does it?
Definitely not. But the mission here is about kind of breaking the laws of physics, or at least the laws of electrical resistance.
That's the whole issue.
We're looking at how you push 18 gigabits of data across a room when copper wire literally wants to stop you.
And it does stop you. We know that limitation. Once you hit, say, 5 meters with a 4K HDR signal, you're really rolling the dice.
You hit that sparkle cliff, as they call it.
Right, where the resistance just kills the bandwidth.
So this NTI cable is the cheat code. I know it's an active optical cable, so it's using light, but usually optical means fiber, and that sounds fragile.
That's a really common misconception. This is actually a hybrid cable.
A hybrid.
Yeah, if you were to slice it open, you'd find 4 fiber optic cores sitting right next to 7 copper conductors.
That sounds like a Frankenstein situation.
Yeah.
You're putting glass and copper inside a tiny 4.5 millimeter tube. It seems like it would snap the first time you bend it.
You'd think so, but the engineering is pretty clever. It's got a bend radius of less than 2 inches. It's surprisingly rugged.
Okay.
And the fiber cores, they do all the heavy lifting, the high-speed video data, 18 gigabits per second.
So you get your full Ultra HD 4K at 60 hertz.
With 0 signal loss. But you still have the copper in there.
Right, so what's that for? The power, I'm guessing. Grounding.
Partly, but it also handles what I'd call the bureaucracy, the handshake data.
Ah, so the ADDD and the HTCP copy protection keys.
Exactly. The hello, I am a Sony TV kind of data.
Yeah.
That low-speed communication travels just fine over copper.
And if that data drops, you don't get a glitchy picture, you just get nothing.
Digital silence.
Yeah.
Exactly. But because the video itself is traveling as light, it has this huge advantage. Total immunity. It doesn't care about electromagnetic interference.
Which explains why the spec sheet lists things like medical imaging and airplane cockpits as use cases.
Right. If you're a surgeon looking at a 4K monitor, you can't have the screen flicker because a power line is running too close to the cable.
Okay, see, that's where I get suspicious about the active part, though. Usually active electronics. That means it needs power. I'm picturing a bulky connector with a messy little USB power cable I have to plug in.
And that is the standard annoyance, you're right. But NTI solved it here.
No.
There's no external power brick. The chipsets and the connectors draw power directly from the HDMI source.
From pin 18, is there really enough juice on that pin?
Just enough. As long as the source delivers a steady 500 milliamps, the cable it powers itself. It's completely plug and play.
That's impressive. It creates a really clean install.
It does. And you don't sacrifice the protocols you care about. It still supports Dolby True HD, DTS HD Master Audio.
And HECP 2.2, which is non-negotiable.
Absolutely. If you want to watch Netflix in 4K, you need that. Or the screen just stays dark.
So let's look at the bottom line. This 10-meter version runs about, what, $174?
It is a premium solution, no doubt about it.
But you're not paying to the brand. You're paying for distance and for reliability.
Precisely. If you need to go 10, 20, or they even have versions up to 100 meters, standard copper simply cannot do that job.
It's the price of admission for a setup that actually works when you hit play.
That's it.
All right, I want to leave you with a thought. We look at a screen and we expect a picture. But with a cable like this, you are converting electricity to photons, shooting them down a glass fiber, and converting them back to electrons.
Billions of times every second.
And you're doing it with 0 perceivable latency. That isn't magic. It's just extreme engineering hiding in a 4mm rubber jacket.
Wow.
Thanks for listening to this deep dive.